Okay, 5th grade lesson 108 is found on page 710. The title of lesson 710 is Schedules, and one of our objectives is learning how to read schedules. The second objective is solve elapsed time problems, which we could all use practice with. The new concept is on the bottom of page 710. It says, in this lesson we will use schedules to solve elapsed time problems. A schedule is a list of times and events that shows when the events are planned to happen. And on page 711 it shows a schedule of events for the state track meet is shown in this program. Daphne qualified to run both the 300-meter low hurdles and the 200-meter dash. Oop, better delete this. Okay, and the 200-meter dash. Her second race starts how many minutes after the start of her first race? If I look at the schedule of events, I can figure out when the 300-meter hurdles start, and they start at 3:10 p.m. The 200-meter dash starts at 3:40 p.m. Okay, if the events are held as scheduled, which of course anybody who goes to track meets understands that sometimes they are not. If they go as scheduled, Daphne's second race will start 30 minutes after her first race. So basically we just take the bigger number, of course, and subtract the smaller number, and we get 30 minutes. Okay? The second race starts 30 minutes after the first race. And this is example 1. If only they were all this simple. Sometimes, however, they don't happen during the same hour, and that's where we run into a little bit more complicated problems. All right, example number 2. Example number 2 says, David planned a round trip from Oklahoma City to Indianapolis and back to Oklahoma City. Here's David's flight itinerary. And on it, they show on August 22nd, at 6:11 he leaves Oklahoma City. He arrives in Chicago at 8:09, and then he leaves from Chicago to Indianapolis, and then it just goes backwards from there. He flies to Indianapolis from Oklahoma City, and then he flies back to Oklahoma City from Indianapolis. It's not just a one-way flight, though. He has to stop and then go to the next place. Now when he's here, he needs to stop at that place and then finish up where he started from. Okay? So it says David needs to change planes on his way to Indianapolis and on his way back from Oklahoma City. In which cities does he change planes? How much time does David have in the schedule to make those plane changes? Okay. It says, we're going to start and just draw it out like this. Okay? David starts his journey in Indianapolis. Okay? He flies to Chicago, and then he arrives in Oklahoma City. Alright? That's how he gets there, and then he obviously follows the same route back. It says David's trips to Indianapolis have 2 legs, one from Oklahoma City to Chicago, and another from Chicago to Indianapolis. He stops in Chicago and has 1 hour and 34 minutes. That's the first answer. He has 1 hour and 34 minutes in the schedule to change planes. This is just called his layover. So he'll arrive in Chicago 1 hour and 34 minutes before his plane needs to leave to Indianapolis. And then on David's return trip, the first leg has the scheduled arrival in St. Louis at 11:03 a.m. The second leg has a scheduled departure at 12:04 p.m. Okay, so it's 12:04 and 11:03. Okay, this is his departure, this is his arrival time. If we subtract the two, we know that he has 1 hour and 1 minute of layover, or 1 hour and 1 minute to reach to get on his other plane. Now I'm going to flip back, and this is the answer, the first answer to example number 2. This is the second answer to example number 2. Alright, this is kind of difficult to kind of understand, I feel like, because you don't get to see the itinerary if you didn't bring your book home. So yeah, we'll cover this and we'll review this when we get back. So hopefully we can kind of have a better understanding of it. Okay, a big part of it is just understanding how to read those schedules. They had a big list, okay, of events and then times. This was for that track beat one. Okay, so say they had a 100-meter dash, a 200, let's just go with a 400, and then an 800. Okay? Now, they also had the times that they were planning on starting them. Let's just say 9:05, 10, 10, 11, 15, and 12:30. At what time, if he runs in the 100-meter dash at 9:05, how much time does he have before he needs to run in the 800-meter dash? Again, you're just taking your larger time, subtracting it from your smaller time. And we know that sometimes that's difficult. We have 12:30 minus, let's say the first one started at 9:05. It's not always really easy to do subtraction in these situations because 0 minus 5, let's borrow. Okay, because we get like 323, as long as we understand that this is the hours, 3 hours, 25 minutes, it usually works. But if it's, let's say we go from 12:30 a.m. to 6:45 p.m. Okay, we understand that we have to go all the way from 12:30 to 1:30 a.m., 2:30, 3:30, 4:30, all the way up to 6:30 p.m. before we can add our 15 minutes to get from 30 to 45. So what I'm going to do right now is get from a.m. to p.m. How many hours do you have to add to go from a.m. to p.m.? Well, I'm going to add 12 hours, and that'll take me to 12:30 p.m. Okay? Now, if I add 6 hours, I'll get from 12:30 p.m. to 6:30 p.m. Okay? Understanding that I'm at 12, now I go back to 1, 2, 3, 4, 5, 6, 30 p.m. Alright? Now to get from 6:30 to 6:45, I add 15 minutes. I add 15 minutes and it takes me to 6:45. Now, the information that we used to get there, we added 12 hours, 6 hours, and 15 minutes. Now you take all of that information, add it up, and that tells you how long it is from 12:30 a.m. to 6:45 p.m. Okay? 12 plus 6 is 18 hours. And we had 15 minutes. Okay? And in 18 hours and 15 minutes, we went from 12:30 a.m. to 6:45 p.m. I would like you to write this answer down. Let's write it down on the example 4 line. Okay? And relatively short, but that's all we have for today. So I hope you watch this. Doesn't really matter to me, but I hope you watch it this weekend so that we can get right to it on Monday. Have a great weekend, and I will see you then.